system of equation. As you can see, for the last lesson, we already talked about this. And who can remind me, what is the solution to a system of equation? Mr. Blanco.
Good morning, Ms. Tran. So now I will say the point where the lines cross.
Perfect.
Or intersect.
Exactly. We call them points of intersection. So look at the first picture real quick, Mr. Blanco. How many times do those two lines meet together for the very first picture?
It looks like only once.
Perfect. So what do you say? How many solutions do they have?
I would say there is only one solution.
Okay. How about you, Mr. Haas? Look like the next picture. What do you think?
The picture in the middle?
Yes.
Well, it looks like these two lines intersect all the time. So
all the time, right?
An infinite number of times. So I would say there's infinitely many solutions.
Perfect. And you can see there are two lines overlap. We have the blue lines and a red line on top of each other. So they are completely meet at so many points. So for that reason, they have many solutions. How about the last picture, Ms. Gonzalez? How many solutions do they have? Or do the line even ever meet?
The lines never cross because they're parallel lines.
Perfect. So do they have any solution?
No, because they're never gonna meet.
Okay, so no solution right there. Awesome, guys. So we got that one. Okay, so I hope that picture stay with you and stick with you. Now we're gonna move on to our goal today is how can I graph a system of equation and be able to find the solution. But before that, I would like to take you back just a little bit to read, review you about how to read a coordinate of a graph. As you can see right here, we have an X and Y coordinate. In order to read a coordinate, we always read X and Y. The X always comes first in the alphabetical order. So let's go ahead and give it a try. Mr. Yamoa, can you read that coordinate of that point? 1 Mississippi, 2 Mississippi, 3 Mississippi. Anyone know the answer? Can you tell me?
3, 4. 3, 4.
Can you hear me? 4. Perfect. Yes, we can hear you now. So here we go. How about this next one right here? If anyone know the answer, just start out the answer right here so we can move on fast.
Excuse me, Miss Tran. I was answering it, but I think my speaker was what do you call it? It was muted, so I'm sorry.
It's okay. We all learning here. So, Mr. Yamoa, can you help me again this one then? What is the coordinate of this point?
That is 2, -3.
-3, 3.
-3 and 3. Okay. So without further ado, I hope that you guys still remember about this. Where the point go, we have X and Y. On the right hand side is always positive for X, and on the left hand side is always negative for X. Up is always positive for Y, and down is always negative for Y. As simple as that, right? And you will practice that as you go. I would like to introduce you another picture. What about this? What about this picture right here? How many graph do you see in this graph right here? How many functions do you see in here?
I see 2.
Perfect. What are they? Can you describe it?
Oh, I see a parabola and I see a linear function.
Perfect. Right? So you see a linear function and a parabola. What is the name for the function have a parabola shape? Do you remember? We did this in Algebra 1, Mr. Blanco. Do you remember?
I don't. Okay, I took Algebra 1 a long time ago, so maybe I don't remember. No, okay, it will be quadratic.
Thank you so much. That's it, perfect. So right here, we have a system, not just linear and linear, but linear and quadratic at the same time. So do you think the same idea of solution still work? Do you think point of intersection is still going to be the solution? What do you think?
I mean, yeah, why not?
Yeah, why not, right? So what do you think? How many intersections do you see in this example? How many times did they meet?
I see 2 points of intersection. 2.
Okay, perfect. 2, right? Do you think you can read that point for me?
-4, 2.
Perfect. Can you read the other solution? Curious about this is that if the points is right on the grid, we might not see it clearly because it's not really close to the grid just yet. So for this one right here, guys, we might have to take it to the calculator to see if we can have a more precise answer. So right here for right now, I'm just gonna put a -7 and 6. But let's read the question together. The question said, which system of equation is represented by the graph? They gave us 4 answers, A, B, C, and D. They want to know what system right here will represent this graph, and they also want to know what is the solution. So what we're gonna do right now, guys, we're gonna go to the calculator and grab them and to see what graph will give in at this answer, okay? Go to decimal. I need everybody please do it with me. You guys, if you do it, you remember it. If you don't do it, then you will forget it. So you type it in the way we've been doing. So negative 5/4, and then x minus 3. Knowing that you can do it on both, on your cell phone and also on your computer, on your Chromebook. And then I type in the second equation. I have y equal negative 3/2, and then x plus 6. Okay, so here we go. Square. If you want to get the square, guy, you have to click on this, and then this is a little power 2 right here, okay? And then plus a, boom. As you can see right here, we can see our graph, right? Did everybody see my graph? Yes or no? Good. I assume that you see it. So here we go. I'm gonna click on the solution. Do we have -4 and 2, Mr. Blanco, just like what you just have? Do we have -4 and 2?
Yes, I see negative 4 and 2.
So let's try this. Do we have the other point?
Yes, and I see negative 7 and 6. I see both.
Yeah, they're approximately around that number, right? It's a decimal. But so that is how you graph. So I don't have to try B and C and D anymore. I already lucky. I really got lucky from the first try. So what is the answer here, Mr. Blanco? What is the answer?
So it looks like it's going to be option A.
Perfect. Sketch an accurate graph of a system of equations and then identify the solution. Okay, so let's do it. Number 1, Ms. Doe, how many equations do you see in number 1, and what are they?
There are 2 equations.
Okay, what type of equation?
The first one is straight. It looks like a linear equation because it looks like a line, only x.
Okay, perfect. I'm gonna do that. You guys hear what Ms. Joe said? She said the first one looked like a line and they only have x, only power 1. So let's try it. Do we have a line? Perfect. How about the second one? What is your guess? What type? What do you expect to see?
It would look like a parabola.
Why? What makes you know that?
They have the square.
Oh, the square, the power 2, right? Do you see the little power that right there? It's gonna give you a power 2. So boom, and then -5. Perfect. We're gonna get a parabola. How many times did this graph meet, guy? Since you are there as well, Ms. Doe, can you tell me how many times this green line and the purple line meet together? How many times they cross?
They cross twice.
Twice. Perfect. So let's read the point together. As you can see, decimal already get the point right there for you. You can click it. If the graph is too small, you can always zoom it. You see, this is how you do, but don't zoom too much. You're gonna go crazy. So zoom up just a little bit. So here you go. Or you always can move it just like this. So now let's read the point. What you got? What is the first solution? We got 1 and 3. Okay. What is the second solution?
-3, -5.
Perfect. And that's all I need. I just need you to write out the solution. Can you tell me if I have an x greater than 2, can you give me an example that greater than 2 that you know? Any number?
3.
Perfect. What else? Give me more.
4, 5, 6, 7, 8, 9, 10, 20, 100
Okay.
million.
Whoa, okay. All that number, love that. How about 2? Do you think I can take 2?
Can you take the number 2 if
Yeah.
it's greater than 3?
Greater than 2.
Any number greater than 2? 3, 4, 5, 6, 7, 8, 9, 10, and so on.
So you're telling me 2 is not included?
If it's greater only,
Yeah.
that's right, it would not be.
Okay, well, don't take that then. How about this one? Mr. Barkley, can you help me out? So I have x greater than and equal to. What could be your example? What could be your number?
Well, all of the numbers that you listed prior would work because it's also equal to, so we would include equal.
Oh, perfect. So
We
this
would
time,
include 2.
yeah, so this time we will take number 2. We will include number 2. So if you still remember from Algebra 2, guys, this is how you go into graph them. When you include, the line going to be a solid line.
That's right.
And the way I remember is a little equal underneath. You will have a solid line when you graph. And I will graph them in a little bit so you can see that as well. But when you not include number 2 right here, you will see the lines here, dash line.
How about if I'm not sure which one is greater than, which one less than?
That's a really perfect question. So let's take it. I have a little trick that to help you remember. It really worked with me in my hand. So I have to take my hand out, right? So right here, if I have my left hand, the way, oh, it doesn't. So here, I'm gonna draw it again. So my left hand, oh my God. Okay, so, okay, excuse my drawing. So this is my left hand, right? The way I remember it less is for left. So you will have a less than sign. Just put your hand out, and then I have the right hand. And the way I remember is the opposite. So it's going to be greater. So right is for greater. Take your hand out every single time that you can feel, and you will remember right is greater, and the way the sign go. And left is less. Okay? Obviously, there are so many ways to do that as well. Whatever way work for you, you should stay with that. I hope I answered your question. So I'm gonna move on over here. Now, the next question is, what are the possible solutions of the following system of inequality? So how can we do that? We are still going to graph with decimal. So let's graph them. But before you graph, always have some kinds of expectation. Mr. Sawan, since you have an awesome question earlier, can you tell me, if I look at this, can you read it for me? What does this sign say?
Yeah, this is greater than.
Perfect. Can you tell me what kinds of line do you expect to see? Dash or solid?
Oh, this is a dash line.
Perfect. Okay, how about this next one right here? What do you expect to see? Dash or solid? And what kind, please help me read the sign first. What sign is that?
It's less than.
And dash or solid?
And it's solid.
Okay, and let's see what Mr. Sawan said is correct or not. Where do we go to grab this guy? Where do we go? Mr. Barkley, where do we go to grab them?
Desmos calculator online.
Perfect. I love that. So let's go ahead and grab the first one. Would you mind to read the first equation for me, please?
Yeah, it's x plus 3y is greater than 6.
X plus 3y greater than 6. Ooh, I did something wrong. So plus 3y greater than 6. So guys, the greatest is ready right here for you, right? Boom. Let's see. Ooh, Mr. Sawana corrects. The lines are dash line. But knowing right here, guys, this is a greater. So you see how the calculator will shade this for you, just like you did in Algebra 1, okay? Let's go ahead and grab the second line. Mr. Barkley, could you please have me read the second line?
Yeah, it is 4x minus 3y.
Just so you know, I really love your energy. 4x minus 3y?
Is less than and equal to 9.
Oh, perfect. Wow. So we also have another line. And as you can see right here, the lines is a solid line, just like Mr. Sawan just said. Thank you, Mr. Sawan and Mr. Barkley. Now, let's talk about the solution. As you can see earlier, we already know. Hey, Mr. Blanco, what did we say about the solution earlier of a system?
So about the system, about the system of inequalities.
The system of equation, the one we just did.
Oh, the equations, the solution is going to be either one point or, I mean, the point of the intersection between.
Exactly. So with the system of equation, the solution will be the points of intersection. Now, how about here? This is a system of inequality. What is the difference? We still have two lines, and do they still meet, Mr. Blanco? They still meet or not?
They still meet, yes, they still meet.
But what is the difference? What do they have different this time?
I would say that the difference is going to be like the region, like the region of the plane where, like, they meet. When I meet, they meet. The shades where the
right, the color, the shading. They right here, as you can see, we have two colors. Earlier, the first one we have a gray, and the other one is another red. Now, what do you think when these two colors meet? What happened? Do they overlap?
So yeah, we're looking for the overlapping region.
Okay, so perfect. I have 4 regions right here. So let me try. Let assume that this is gonna be my region number 1.
Yeah, let me see. Miss Sam, do you mind if I point it out on? All right, let me see if I point it out. So this is 1, right?
Yes.
Right?
Yes.
Let me put it right. And the other one.
How about I write down number for you? Number 1, number 2, number 3, and number 4.
Yeah. So I always look for where these lines meet together, right? like that. So there's going to be my answer.
Okay, so as Mr. Blanco pointed out for us, he are pointing at the region where the two color are overlap. That's going to be our solution this time. Now, do we only have one solution, or maybe we have a lot of solutions? Let's talk about it. Can somebody give me a point, a solution that in that region where they overlap? Mr. Yamor, if you are with us, can you give me a point that you think going to be a solution? What point is that?
That would be, oh.
Okay, Mr. Yamor somewhere. So let's somebody else help out your buddy. Who can help? Let's go. Can you please give me a point?
Can you hear me? Yeah. Can you hear me?
Okay, what happened to all my students? So can somebody give me a
it's
point?
0.
Could be anybody.
0.5.
Well, let's take one answer now.
0.2?
No. Well,
what happened? Where
0.2 would not be a solution because it's on a dashed line.
Hello?
5.5?
0.2.
0.2 would not be a solution because it's on a dashed line.
I think her sound is off.
Can you hear me? I can't hear anyone.
0.2.
You need to turn up the volume.
On the dash line.
0.15.
Turn up. Turn up.
0.5.
I don't hear
Hey,
anyone at all.
Mr. Man, is 0.2 a solution? Because Barkley says 0.2 is on the dash line, and I don't see it on the dash line.
0.2 is on the dash line.
I think her volume is not on. Her volume. That's why she couldn't hear us.
In order to be a solution, it has to be in the shaded area or on a solid line.
Miss Tran, you need to turn up your volume. Volume.
I don't hear anyone at all.
Miss Tran, turn up the volume. Can you hear us now?
Yes. Oh no.
Okay. Because earlier I saw your volume was off.
Hey, this is what you see your teacher struggling on a video. Should we put this on the video or cut it off? Oh my God. Okay, so can you give me a point that a solution?
We all try to give you solution like for the last 5 minutes.
Can someone tell me an answer, please?
I said 0.5. Is it correct? Because you didn't say anything back.
Yeah. Yes, that's the solution.
Yes, what is that?
Ms. Tran, are you there?
Yeah, I'm here. Can you hear me?
Yes. Was I correct or wrong?
I didn't hear you earlier. Could you please give me the points again one more time?
0.5.
0 and 5. Lovely. That is a correct answer. All right. 0 and 5 are completely in that region, so it is a solution. How about this one? I like this one. How about this one? 5 and -5. What do you guys think? Mr. Yamoa?
Oh, what did I, so 5, -5 is not a solution.
Why not?
Because for it to be in a solution, it should be in the region of all the possible solutions, and it's not, which is the shaded area.
Exactly. So we need to be in here, right?
Shaded area.
Overlapping. That perfect keyword right there. So gotta be in there. How about here? How about this point right here? How about this one, Mr. Yamoa? What do you think? And can you read me the coordinate as well?
I learned one of my peers said that the solution should be either in the overlapping or on a solid line. Oh. So what you ask, that point is on the solid line, so it qualifies to be a solution. Perfect.
And the point is 6, fine. So if you guys hear what Mr. Yamoa just said, it gotta be in the shaded area. It had to be at the overlapping region and also on a solid line, meaning that if the point's on here, do you think it's gonna be a solution then?
No, because it's on the, what do you call it? Is it dotted line or the broken line?
Okay, we
It's
don't
not a
want that.
solid line.
And it's not included. Okay, Mr. Yamua, so what you said is perfectly right. You said that in order to be a solution, it has to be on a shaded area. It's also on the solid line. So what about this point right here? It's a little half and half right here. I'm on the intersection of, I'm on the solid line. I'm also on the shaded region, but I also on the dotted line, like the dashed line. Do you think it's gonna be a solution or not?
You know, that for it to be a solution, it has to satisfy both inequalities. And unfortunately, it doesn't satisfy one of them. So therefore, it doesn't qualify to be a solution.
Oh, perfect. That's perfectly well said. So in order to be a solution, they have to satisfy both, right? So yes, I'm on the solid line. So I satisfy the solid line, but I'm on the dashed line. So I'm not qualified. So for that reason, 3 and 1 will not be a solution, okay? So make sure you keep this in mind. It's going to be on the test someday. Okay. So why don't we give it a try right here for the question. What does it mean to be a solution of a system of inequality? What do you think, Mr. Sawan?
Any points that will satisfy both inequalities.
Okay, perfect. So I'm going to satisfy both inequality. Okay, that's lovely. I hope you can read my handwriting. If you cannot read it, you hear my voice. So here I go. Now, how about the second question? How do you solve for the system of inequality? What do we do, Ms. Doe? What do we do for this one? Where do we go?
We solve by graphing each individual inequality on Desmo.com, and then we find the overlaps of the solution.
Okay.
The portion.
Okay, perfect. So we're gonna graph them and we are looking for the overlap region, right? So perfect. Okay, say the best for last. So right here, overlap shaded region. Okay. Here you go. Say the best for last, Mr. Barkley. How do you know if a point is a solution of a system? How do we know?
Okay, the point lies inside the overlapped area or on a solid line.
Okay, lovely. So inside the overlap.
Which Mr. Haas did earlier, when you plug in the point to both equations, it is true in both equations.
So that means they have to be on the shaded line or dashed line?
That's right. If you plug in that point into the original equations and it's true in both inequalities, I should say, it's true on both lines, it is a solution to that system of inequalities.
Okay, lovely.
Now, we are not going to be teaching them how to plug in and do that, are we?
No, we're not.
Okay.
So I think, Mr. Barkley, for this answer, I think we just need to say that they inside the overlap areas and on the shaded line.
Yeah, okay.
Yeah, so can we do that again? Just that take.
Yeah, the point lies.
Hold on, I'm not ready. Okay. So here we go. All right, guys. So say the best for the last right here. How do you know if a point is a solution of a system of inequality? How do we know that, Mr. Barkley?
The coordinate point lies inside the overlapped area or on a solid line.
Okay, they have to be inside the overlap area. And they have to be, what did you just say again? Can you say one more time?
Or on a solid line.
Okay, they're on the solid line. Okay, perfect. All right, so I hope that makes sense to you guys. So I only have the last one left. Okay, stay with me. Don't exit out yet. I'm gonna go into number 5. Okay, number 5 right here. The little difference with number 5 is that instead of a system of 2 inequalities, they have 3 inequalities this time. So let's grab them all together. I would love if everybody doing this with me at the same time so we can check it out together. So we're gonna go to Desmo.com. Okay, so here we go. So number 5, Mr. Haas, can you help us? What do you expect for the first line? The line gonna be dashed or solid?
I expect the first line to be solid.
Perfect. So let's check it out. Let's see what he said is correct. Bingo. And he got it correctly. So how about the second line, Mr. Haas? Can you help me as well? Dashed or solid?
The second line has an equal sign under it, so it will also be solid.
Lovely. Did you hear what he said? Always remember that, okay? If you have an an equal sign underneath, it's gonna be a solid. Now, what I would like to share with you a little tip. Whenever you wanna grab a system of 3, you go, it might be gonna be a little bit confused because the color are mixing together and overlap. But before I grab number 3, I would like to ask you an expectation first. What do you expect the solution, the shaded region gonna be? So I'm gonna give you a couple numbers, okay? So bear with me, hand in here. So I'm gonna have quadrant number 1, quadrant number 2, and quadrant number 3, and quadrant number 4. Where do I expect my solution have to be? On quadrant number 1, 2, 3, or 4, Ms. Doe? What do you think? My solution, my shaded, my overlap, gonna be on number 1, 2, 3, or 4. What do you think, Ms. Doe?
1.
Perfect.
I think
Okay.
number 1.
Perfect. Do you see why the color overlap? And let me tell you why I doing that. Because I'm going to grab the third line right now. So my third line going to be 6y, no 6x, my bad, plus 3y less than 12. The reason I'm doing it is because when you add more color or when you add more line, you will be confused by knowing where the solution area going to be. But we already have an expectation, right? We already have the expectation that the solution have to be on number 1, meaning I don't care about the rest. So my solution gonna be what? Can, oops, draw. So here we go. I'm gonna draw. Can my solution be in number 2 anywhere in here? What do you think, Mr. Blanco? Can my solution in here?
No.
No, because we already said it, right? We already said at the beginning. Gotta be in number 1. So it's not gonna be number 3, and who cares? Not even look at it. Not even number 4, who cares? Not even bother. But what exactly in number 1 that we're not looking at? Should I look at it here? Is my solution gonna be here, Mr. Blanco?
No.
No, where?
No.
Oh,
No.
what shape is that? What do you see?
It's going to be the triangle.
Exactly, perfect.
Yeah,
that one with a little dashed line right here. So that will help you find the solution easier. If you read the instruction, I do ask for 3 points. So Mr. Blanco, would you mind to give me 3 solution points that in this area? Can you give me 3 points, please?
Like 3, one can be 0, 0.
Okay, lovely. Right at the origin, 0, 0. I'm gonna try to change the color.
Yeah, that can be 1. Another one can be 1, 1.
Okay, 1, 1. You see it completely inside, right? Here we go.
And 1, 2.
1, 2, 1, 2. Oh, you're giving it a tricky point. What do you think the answer gonna be?
That's it. You say it's small. I cannot see it. So skip it. Forget about that one.
Why we forget about this one though? Why this one is not a solution?
Because it's on the dotted line. It has
exactly.
To be, yeah.
It's on the dotted line. We don't take it. We only take it full.
Other one can be 0, 2.
0, 2. Lovely. Okay. So here we go. So that does conclude our lesson today. I really hope it does make sense to you. If it not make sense, please watch this video 10,000 more times. Hopefully it will make sense for you. And please don't forget to do your homework. Okay. See you next time, class. Bye.